No? Mm-hmm.
Bona electrically. She comes there. I mean, they say Bona. All time to learn the music. From there, they go hear you say, okay, for now, I put something. And that is for the thing. Something I come to using your I learned that and at least I never hear this for HK, matter for HK. All those guidelines they will make people believe. Then you go and that for that you need for that now. You need experience. They teach everything. Experience. They teach everything. So now that's for that. If you want to start now, if you want to start for that, anybody now, some now, like some now, if you want now for you, 8,000, but if you get really that.
So good evening. Our today's class is going to be a continuation of last week.
Thank you, sir.
Again, so if now no one to at least every two you will buy go for sorry, you will buy 3x, 4x, you understand? That's no for 0.5, see that kind of important. If they buy that slot to give the investor,
Okay, good day. Our today's class is going to be electrical engineering science as usual. So today's discussion is electrostatics 2. And what we are going to discuss is capacitor. So as you know, capacitor is a device that stores electrical energy in an electrical field. It is a passive electronic component with two terminals. So, and the effect of a capacitor is known as capacitance. Wait a bit, I'm coming.
Okay, for you, sir. You give me 100 naira.
And so, as we said, a capacitor is a device that stores electrical energy. So, you know, electricity is also a form of energy, just as we discussed in our previous classes. And one thing that you use in storing electricity is a capacitor. And so, just as we said, you know, a battery is also used in storing electrical energy. But there are some differences between a capacitor and a battery. Now, a battery will take time before it charges, and it will take time before it discharges. Whereas a capacitor takes short time to charge and short time to discharge. So that's one of the basic differences between the two. And this capacitor can be used in forming some energy storage devices. It is better than battery in the sense that it has almost more than the charge and discharge cycle of capacitor is more than that of a battery. So you know, battery life is determined by how many times it can charge and discharge. So if a battery has a life or a battery cycle of 500 charge and discharge cycles, so after that 500 charge and discharge cycle, it is going to die. Whereas a capacitor can have more than that amount of charge and discharge cycle. So you can use it in some places. There are some type of capacitors um, called they are called super capacitors. So those ones can be used in forming a sort of a battery. So it is a passive electronic component with two terminals. What we mean by passive is you cannot use it to amplify energy. You cannot use it to have power gain. You know, electrical components or electronic components are divided into two. It's either you have an active component or a passive component. An active component, an example is a transistor. So you can use transistor in order to boost energy, in order to boost power. Whereas with capacitor, resistor, inductor, you cannot use it to boost power. So active components require power supply. That's why your radio set, your amplifier, they will require you to supply them with a battery or a form of DC supply. So, but for capacitor to work, it doesn't require any battery. So now, the characteristics of a capacitor is called capacitance. Now, this picture is showing some of the pictures of capacitors. All these ones, they can come in different forms. All these ones, even these small ones, they are all different form of capacitors, which are used for different applications. So you just look at the application that is appropriate and you make use of it. Then, you know, in engineering, anything that we do, we like symbols, just like mathematics. So the symbols for capacitor is either you see this one as your symbol for capacitor, or this one as a symbol for capacitor. This one with an arrow here is a variable capacitor, whereas this one is a polarized capacitor, whereas this one is a fixed capacitor. So you can see a capacitor is a two-terminal devices. By two-terminal devices, we mean you have one terminal here, another terminal here. You can see one terminal here, another terminal here. All of them, you'll see that they have 1, 1, 1, 1, like that. So, you know, some of the electronic components, they are three-terminal devices like transistor, but for capacitor, it's a two-terminal device. So you can connect capacitors in parallel. So when you connect them in parallel, you will have capacitance, which is represented as C1, and this C1 will store charge Q1. Then you also have second capacitor, which is C2, which will store charge Q2. And you have the third capacitor, which is C3, which will store charge Q3. So whenever you pass current from your source, your voltage source, which can be DC voltage source like this one, it is going to come all the way to this point A. At point A, charges, some of the charges will divide. Some will follow here, some will come here, and some will come here. So since the charges are dividing at this point, it means the total charge that is being supplied by this battery or that is being stored by these three capacitors is Q1 plus Q2 plus Q3. So this is total charge. Now capacitors connected in parallel. So we can see that this is the total charge. And you could remember that the relationship between charge, capacitance, and voltage is given by this. Qt is equals to CV. So it implies that Q1 is equals to C1V, where and Q2 is equals to C2V, Q3 is equals to C3V. So we are using V without any notation because the voltage drop across the three capacitors is the same. So because they are connected in parallel. So where C is the total capacitance. So now we are trying to find the effective capacitance of these three capacitors connected in parallel. Meaning if you connect a capacitor C1, C2, and C3 in parallel, what is their total capacitance? What is the effect of the three in this configuration? So that total capacitance is given as C. So and the total charge is CV. So CV is going to be C1V plus C2V plus C3V. We are just taking this equation Qt is equals to Q1 plus Q2 plus Q3. So wherever we have Qt, we replace it with CV. When we have Q1, since Q1 is equals to C1V1, C1V, we replace it with C1V. Similarly, Q2, we replace it with this Q3 like that. So C is the total equivalent circuit capacitance. So you can see we can factor out V from these three terms. V is common, so you can factor it out. So once you factor this V out, they are going to cancel out. And all you'll be left with is C is equals to C1 plus C2 plus C3. So that is for three capacitors. What if you have more than three capacitors? So for more than three capacitors, if you have up to n capacitors connected in parallel, so you'll just be adding them C1 plus C2 plus C3 plus C4 plus C5 up to Cn, where n is the number of capacitors connected in parallel. So the next configuration is capacitors connected in series. So when you connect them in series, you know we say series connection is end-to-end connection. So okay, end to beginning connection. So the end of this is connected to the beginning of this. The end of this connected to the beginning of this, like that. So when you connect them in series, you are going to have them like this. Now for any series connection, you could remember that the voltage drop across them is going to be different. So the voltage drop across capacitor C1 will be V1. Voltage drop across capacitor C2 will be V2. And voltage drop across capacitor C3 is going to be V3. Okay, then you can see charge on capacitor Q. So since the same voltage is, since the same current is going to pass through them, it means they are going to store the same charges. You remember we say that you look at, we say Q is equals to IT. So since the same current is going to pass through them, taking the same time, it means the charge through them is going to be the same. So that's why we say Q and minus Q, Q minus Q, Q minus Q. So the charge is the same. So now, in essence, for a series circuit, V is equals to V1 plus V2 plus V3. That is the voltage drop across. The voltage drop across.
Cover.
So you can see that the total voltage is equals to V1 plus V2 plus V3. So that's what we represented here. So the total voltage is V equals to V1 plus V2 plus V3. Now, since V is equals to Q over C, you remember here we say that Q is equals to CV. So if you make V the subject of the formula, then V will be equals to Q over C. So V is equals to Q over C. Then it means this V, which is Q over C, is going to be Q over C1 plus Q over C2 plus Q over C3. So you can see that the Q, we say the charge through them is the same. So where C is the total equivalent circuit capacitance. Remember, we are trying to find what is going to be the effective value of these capacitors connected in series. When you do that, you are going to have the effective capacitance 1 over C is equals to 1 over C1 plus 1 over C2 plus 1 over C3. Because if you look at Q here, Q is common to these three terms. So you can factor it out. And once you factor it out, this Q and this Q can cancel one another. So you are going to be left with 1 over C is equals to 1 over C1 plus 1 over C2 plus 1 over C3. So now this is a situation where you have three capacitors in series. What if you have them, if you have more than three? So for more than three, you can just extend the formula to be plus 1 over C3 plus 1 over C4 plus 1 over C5 up to plus 1 over Cn. That is up to the number of capacitors in series. So now you can remember from the beginning of the class, we say that capacitors store charges. So since capacitors store charges, in a capacitor, what is the amount of the charge stored by a capacitor? So the amount of charge stored by a capacitor is given by W is equals to half CV square, and you know energy is stored in joules. Okay, sorry, I said amount of charge. That energy stored in capacitor. So the energy stored in capacitor, the formula is given as W is equals to 1 over 2 CV square. We are not going to derive the formula here, but you should take note of it. It's useful. Now, you know, in engineering or in science, anything that you do, you should be able to measure it. So we are trying to measure the energy that is being stored by a capacitor. And this formula will give us that amount. So here is a numerical example, which is saying you're having three capacitors. One is 3 farad, another one is 6 farad, another one is 12 farad, which are connected in series across 350 volt supply. Now, I forgot to tell you that capacitance is measured in farad, and this farad is one big unit. So most of the times you will see that the unit is in sub multiples of farad. That's microfarad. That's 1 farad divided by a million. So most of the components, that's their values. So now you have them connected in series across a 350 volt supply. Calculate A, the equivalent circuit capacitance, B, the charge on each capacitor, and C, the potential difference across each capacitor. So these are three questions which you should be able to answer. Now the equivalent capacitance for series connection. So as I used to tell you that anything you do, you try to quote the formula first. So the formula for series connection is this. So it's just a matter of substitution. You just say your 1 over C, which your C is the equivalent capacitance that we want to find for option A. So you have 1 over 3 plus 1 over 6 plus 1 over 12. So the next thing you do, you find the LCM of 3, 6, and 12, which is 12 itself, because 3 can enter 12 up to 4 times, and 6 can enter 12 up to 2 times, and 12 can enter 12 up to 1 times. So that's why we say the LCM is 12. So 12 divided by 3 will give you 4. 4 times 1 is 4. 12 divided by 6 is 2. 2 times 1 is 2. 12 divided by 12 is 1. 1 times 1 is 1. So you are going to have 4 plus 2 plus 1, which is equal to 7, all over 12. Now, mind you, here is 1 over C, and we are looking for C. We are looking for C. So it's a matter of finding the inverse of both sides. And when you take the inverse of 1 over C, you are going to get C. And the inverse of 7 over 12 is just saying 12 over 7. So this is the same thing as 1 whole number 5 over 7 farad. Here is going to be farad, not microfarad, because all we are given in the question is in farad, not microfarad. You can see they are all in farad. So here that you have microfarad is actually wrong. So option B, in question number B, it is saying you should find the total charge. And you remember we said the total charge is given as Q is equals to CV. So we have already found our C, and we know V, which is given as V is given as 350 volt supply. So we just plug in our values, which is 12 over 7. Still here, we are saying we are using microfarad. So if it is microfarad, that's when you put this. So times 350, and this is going to give you 600 microcoulomb, or 0.6 millicoulomb. Since the capacitors are in series, 0.6 millicoulomb is the charge on each of them. So you remember we say for series capacitors, they will have the same charges. So the overall charge is the same for all of them. Now the voltage across 3 microfarad capacitor V1 is equal to Q over C1. And this is going to be equal to 0.6 times 10 raised to power minus 3, because this is milli, you have to convert it, all over 3 times 10 raised to power minus 6, which is the value for C1. If we take it as V2, I mean, if we take it as in millicoulombs, so the answer is given as 200 volts. Now I have a classwork for you, which is this, but before the classwork, if you have any questions, you can ask so that we can answer before we proceed with the classwork, which you are going to submit in your WhatsApp. So any questions? Okay, Ismail, Al-Hassan Ismail, go ahead with your question.
Yes, sir. So, with this question, voltage drop, sir, I don't clearly understand.
Which voltage drop?
The one you explained.
Okay, let me go with the slide. So whenever you see it, just which one is it? Is it this slide?
Yes, yes.
So which of them? Number A or B or C? Huh? Which number?
Number B.
Number B? Huh?
Yes.
Okay.
Yes.
Okay.
Number B.
It is
Number B.
okay. It is already given in the question now. If you look at it, here we say the
Okay, sir.
it's given as 350 volt supply. So that is the voltage drop.
I did lectures.
Do you understand? You understand? Ismail, do you understand? Okay, I think let's go to the next question.
Yes, sir.
Okay. Samuel Anujurum, do you have any question?
No, sir.
Okay, anybody with any question? There is somebody here with 03825. Any questions? So let's just go with for the classwork, which you are going to submit in your WhatsApp in the next 10 minutes. So this is the classwork, just copy it down and you submit in the WhatsApp group. Are you done with copying?
No, sir.
Okay, what we'll do, I will just share it. For those of you that haven't finished copying, I will just share it in the WhatsApp group. I will share the slide in the WhatsApp group so that you can just solve the questions. Have a nice day. Thank you.
Okay, sir.
Thank you, sir.
Thank you, sir. Guy.
Yeah, how you doing?
Fine. Sir.
How things now today?
Just chill, man. Just
Which kind of
chill. Just chill.